Hey guys, what's up? Okay, so today's video is a revision one, as I haven't done that in a while, in which today I'm actually going to be talking about what's A-level electron configuration and for the A-level chemistry, and I'm going to be showing you guys a nice little technique I created. Okay, so let's get on with the video. Okay, for my method, which I'm going to actually be starting off with, the requirements for it is you need to understand how the orbitals work. Like, for example, S orbital has a maximum of 2. Well, technically all orbitals have 2, but it's overall about the type of orbital during it. So that's the main part, and also knowing in your GCSE electron configurations. That's all it is. It's so, now to get into the method. Okay, with my method, the first thing you should do is to look at the electron number of your element. For example, say it's titanium. That one is electron configuration 22. So you'd first put it into the GCSE system, which identifies it to be 2884. In which this is highly effective because these are the shells. Now you have to put them in the subshells. So it would become 1s squared, 2s squared, 2p hex, 3s squared, 3p hex, 4s squared, and 3d squared. Overall, you might be curious why I called the last one 3D instead of 4D. But it's actually because shell 3 can actually hold up to 18 electrons, and whereas something like 2 can only really hold 8. This mainly uses the period system, which is used in the GCSE. So this is highly effective for that logic, because you can actually use your new equation to see whether you've got it correct. That's because you can actually transfer it into the GCSE, which can be highly efficient. And if you want that kind of thing. Okay, now on to the exceptions to the rule. For example, let's start off when ionizing. When you ionize a material, such as titanium, it's actually the s orbital on the outside that loses it first, not the d. So if it was titanium 2 plus, its one would be very much the same, just without the 4s squared in there. Yeah, so that's going to be something, and it will be eliminated. But another of the two, which are highly interesting, are actually the chromium and copper. They actually don't abide to the normal rules. Because in fact, chromium is one, and at its outer shell, and the last two is 4s to the power of 1 and 3d E5. This does not abide to the normal rules. Which, personally, I don't know why. I'll try and figure it out one day. Okay. With copper, it wants to fill all the d electron spaces first. Yes, so that means that it would actually develop one which is 4s to the power of 1 and 3d to the power of 10, which is the maxima. that type can hold, which is highly interesting in this situation, and because it's actually causing a problem, which personally I don't understand. And so you just have to think about these things when you're actually using my method. Which other advantage of it is you can actually use the method of the GCSE to check your method. Because if you look at throughout each period, it actually does add up to the GCSE one. So, yeah, that's it for this video. Hopefully you smash that like button, smash the subscribe button, and I'll be posting more soon. Huh? What's happening?
Hello, this is Dark Rex. I can see the hacker hasn't been taking heed of my words. He's just carrying on. But what I can say is that with his channel, what he has been developing for 4 years straight, it's going to come to an end soon or another. He'll just see it dwindle away, and he won't